And why standards matter for business on an overall basis, I'll point out a few things. Standards establish specifications and procedures designed to improve product compatibility, facilitate interoperability, simplify product development, and speed time to market. They improve reliability of the process, products, and services people use every day. They provide confidence in new products or technologies through consistent verification of claims. I'm bringing these up because many of these themes will be part of the case study. Standards create new markets for products. They lend credibility to newcomers to quickly penetrate global markets. They align future technical developments with corporate strategies. The case study on IEEE 515 will show how many of these affected the heat tracing market. First of all, I think it'd be important to explain what is heat tracing. A heat tracer is attached to a pipe as shown here. Heat tracer. This is a pipe, and it runs the length of the pipe. Heat flows from the tracer into the pipe. The pipe is then covered with thermal insulation to reduce the heat loss from the pipe. The primary applications are freeze protection, process temperature maintenance, and condensation prevention. On a pipe containing water, the heat from the tracer keeps the pipe above freezing when the outside temperatures are low. Prevents freezing, the pipe doesn't break. Oil and many process fluids have relatively high viscosities at room temperature, like honey in a jar trying to pour it out at room temperature. In order to pump these fluids through pipes, they need to be at much higher temperatures. Trace heating is used to maintain the pipes at elevated temperatures where the viscosity is lower and the fluid will flow like water. On gas sampling lines, it is important to maintain the tube temperatures above the dew point of the gas to prevent liquid from reaching the instrument. In the 1970s, there were two types of heat tracing, steam and electric. Steam tracing was the traditional method. Steam tracing provided heat to the pipe through the condensation process. Electrical tracing provided heat by what we call I²R heating or Joule heating in a metallic element, or at the time, a just recently introduced conductive polymer element. It is important to note that in the 1970s, steam tracing was the dominant method. Electric trace heating was only 10% of the market. Even if electric trace heating could go from 10% share to a 20% share, that doesn't sound like much, it would double the business for electrical heat tracing suppliers. Electrical trace heating had many advantages over steam tracing, and it had potential to increase market share. Unlike steam tracing, electrical tracing could provide accurate temperature control. Control and monitoring of the system could be done at a remote location. Electric tracing was much more energy efficient. electric tracing was clean. Steam frequently had leaks. Steam tracing is based on and requires a supply piping. At the end of the steam tracing circuit, there's a steam trap assembly, and then there's another line which we call the condensate return. For electric, all you needed was a power connection and an end seal at the far end. This resulted in ease of installation for electric tracing and a lower total installed cost. However, I should point out that steam always provided plenty of heat. All sites at the time had maintenance staff that could install steam tracing and maintain it. And in explosive atmospheres, steam was proven to be safe. I should point out, heat tracing is often installed in what we call explosive atmospheres, such in refineries, where a spark or a hot surface can cause an explosion or a fire. Here are the challenges facing electrical heat tracing in the 1970s. Then, users were familiar with steam. Many users were not familiar with electric tracing. It was new and unproven. Users had concerns: reliability, suitability of the product for the application, safety in explosive atmospheres, lack of ability to compare performance features of electrical trace heating products between manufacturers, no consistent design and installation techniques, no common standard for agencies to certify to, such as verifying performance or establishing safe operation in hazardous areas. The answer to expanding market share of electrical heat tracing was then to develop a standard that would address the following. It would establish minimum tracer construction requirements for the application, provide the basis for tracer performance ratings, provide requirements for approval agency certification in explosive atmospheres. IEEE, this would become then IEEE 515, recommended practice for the testing, design, installation, and maintenance of electrical resistance trace heating for industrial applications. Some standards are driven by government requirements, but IEEE 515 was driven primarily by economics and safety concerns. Manufacturers, users, and regulators had to get their arms around technology, agree on the best testing procedures, and present a standard in a way that these systems could be more safely installed. The first step in the process was initiating what we call a project authorization request, PAR. This was done by the Petroleum and Chemical Industry Technical Committee of IEEE. PCIC was the sponsor for this standard. After the project was accepted by IEEE, a working group, this is the group that develops the standard, of interested individuals with technical understanding and leadership skills who could work together to develop the best consensus solution to the challenge was formed. The IEEE 515 working group had a balance of interests: users, manufacturers, and approval agencies. It took 4 years to complete IEEE 515, which was first published in 1983 as a recommended practice. Were there conflicts during the development of IEEE 515? Of course. Sorting out the best way to test has been a challenge for working groups over the decades, as different individuals want different testing methods. All standards require give and take. During those early years, there were many points that needed agreement, and key technical issues had to be hashed out within the working group. I thought I'd point out that when there was a difference of opinion on the requirements, we looked at user input and usually considered that on a preference basis. Through compliance to the standard, manufacturers would have to demonstrate the ability to predict that their product would work consistently and safely. What's in the IEEE 515 standard? Briefly, I'll just list some of the requirements. It had electrical test to ensure adequate electrical dielectric protection. Mechanical test to make sure that the heat tracing is durable enough for the application. Environmental test for water and exposure to fire. Performance tests to verify manufacturers' power output ratings. A test to establish reliability and long-term operation. And tests to verify the manufacturer's ability to predict maximum tracer temperature for explosive atmospheres, a key safety issue. Design, installation, and maintenance recommendations were also included. On the left here, you can see this is a commissioning record. I don't expect you to read that, but I'll point out this provides the user with tests and documentation that will ensure that the heat tracing installation was done per the design and that the system is functioning to the specifications. On the right is a maintenance log record. This gives the user guidelines on keeping his system operational year after year. With these two documents in IEEE 515, the user could be assured that his heat trace system was installed correctly and that it was fully functional after a periodic check. Now for the important part. Once IEEE 515 was initially released, its impact was clear and immediate. Users in the process industry began using electric trace heating systems with confidence. Word quickly spread as confidence in the electric heat tracing technology grew. Within the petroleum and chemical industry, new applications surfaced, and the results met the expectations. Now, many industries use heat tracing, electrical heat tracing, in one form or another. It is unlikely that this would have been possible without IEEE 515 in place to help ensure that the systems worked well and could operate safely. You might be interested in this. We talked about water and oil. However, as Mr. Johnson of Thermon Industries said, there are so many applications of electrical heat tracing. In addition to the petroleum and chemical applications, here are a few others. In the cosmetics industry, lipstick has been kept at even temperatures during production. The pharmaceutical industry uses electrical trace heating in its production facilities. In beer production, the acceptable variance in temperature is very narrow. So there are applications in this business for electrical heat tracing too. For the same reasons, the food process industry uses electrical trace heating in the manufacture of soup, chocolate, fats, and grease. Expanding to these applications was largely due to the acceptance of electrical tracing as a viable method. Again, the standard helped do that. Thought you might like to see some examples of users of electrical heat tracing. In the left column, you can see well-known oil and chemical companies such as Shell, Dow Chemical, Exxon, BASF. I have been to plants here in China, BASF and Dow, not too far away from Shanghai. On the right side, you can see other major users such as Procter & Gamble, Alcoa, General Motors. I think there's quite a few Buicks I've seen around China. As mentioned at the beginning of the presentation, in IEEE Standard working groups, balance is important and we like to have user participation. Throughout its development and subsequent revisions in 515, we've had user representation from the companies listed here in blue. Here are some quotes on why 515 matters. I would say in the interest of time, these are something we will hand out, and so we won't go over these right now. You can find them in the handout. There was a huge growth in revenues of the manufacturers of electrical heat tracing from the mid-1970s. Not only did the process industry grow, but due to the advantages of electrical tracing over steam, the market share of electrical tracing increased from 10% in 1970s to nearly 50% today. The red bar shows the approximate size in millions of US dollars for the mid-70s and the present, and it's pretty significant. You see here to here. The key for this growth was the acceptance of electrical heat tracing. No active standard remains stagnant. IEEE has rules with regard to revising and reaffirming a standard. Because electrical heat tracing products and technologies have changed over the years, IEEE 515 has always had a full revision and never been simply reaffirmed without change. I'll point out that after the initial publishing in 1983, there have been 4 subsequent revisions in the years 1989, 1997, 2004, and most recently 2011, and I've been part of every one of those. One of the major advances over the years is the drive towards internationalization of 515. Okay. I think I'll just point out, in the interest of time again, that there's been a lot of work going towards internationalization, and the next slide, I believe, shows where it's headed today. In this particular case, we are working with IEC in what would be called a joint development. IEC and IEEE have agreed to a joint development to recognize or harmonize IEEE 515 and its counterpart, IEC 60079-30, in the next few years to create a global standard for electrical heat tracing applications. This will be called IEC/IEEE 60079-30. In summary, in the mid-1970s, electrical heat tracing was relatively a new method to accomplish heat tracing. Users needed more confidence in the method, interoperability, reliability, consistency, and safety. IEEE 515 addressed these concerns, and electrical heat tracing became an accepted means of heat tracing. Manufacturers revenues increased more than 20-fold over the decades since the inception of IEEE 515 as they provided their products and support services to help solve more and more trace heating needs. IEEE 515 boosted confidence in electrical heat tracing and changed the process industry forever. You can find out more about standards. I'll point out the website. If you want to get a standard, here's where you can find the standards, and here's our general website for the IEEE Standards Association. You can learn more about the standards process. With that, I'll thank you and close and ask if there's any questions.